efficient. So implicit is actually one of the biggest contribution by Limbitz, which is, he's actually the first person that really talk about implicit derivatives. So I'm going to go through some basic rule on implicit derivatives. Some basic rule like d to the dx to the x cubed. Now, even though this is like this, there's still implicit happen. So I'm going to try to tell you is you taking derivative with respect to x here, this is just normal power rule. But still, the chain rule still involved. Usually people don't see this, or teacher doesn't write down this because they don't think kids should be able to see this. But it's dx over dx. There's still chain rule. You're still taking derivative of x with respect to x. Does that confuse you? I'm still taking derivative x with respect to x, so that's equal to 1. So therefore, it's 3x squared. Even though it's not there visibly, you don't have to write this. This one, you don't have to write it when you're taking 3x squared, but it's still happening. The reason being is, what if I have d to the dx to the y to the cube? Then you will have 3y squared dy dx. So now it becomes important. Does that make sense? Okay. How about negative 3x squared y to the third? And if I say d to the dx on those. Now, I will tell you, like my habit. Okay, my habit was probably not the best habit, but usually it will guide student in the right path. I usually take the negative 3 out, just kind of outside in the front, because negative 3 is a constant multiple rule. So I can just can focus on derivative x squared y to the cube. I can just take the negative 3 out, and I'll do the negative 3, and now I'm going to do derivative respect to x of x squared y to the cube. What do you think derivative of x squared y to the cube is? Yeah, but what else? Besides chain rule, what else? There is a product rule, right? So there's a product rule, and when you deal with the y, there's a chain rule. When you deal with x, there's no chain rule. What it does, it has dx over dx. We just don't write it. So therefore, if I take a derivative just x squared, I'm going to get 2x. But dx, I don't write. So anytime you take a derivative with respect to x, you don't have to write that term. But if you have y to the cube, now I'm going to say it's x squared times 3y squared, right? Because you still have to take a derivative of y to the cube, and then it's 3y squared times dy dx. Does that make sense? So then now I distribute that because that makes a lot easier rather than trying to do it with it inside. I just my habit doing things. You can choose either way, but I do think that I just want to make sure all the student does right. So y to the cube minus 9, I believe. Minus 9 x squared y squared dy dx. But you know dy dx is the derivative, right? It just is the same notation, right? Same notation. Oh, sorry. Right? dy dx is equal to f prime of x or y prime. So I'm going to find the derivative of these functions. This function, I'm just take an example. That's a x cubed minus 2xy plus maybe y squared is equal to 10. I want to find dy dx. And why do I need to know implicit? Because I cannot take a derivative explicitly. I cannot solve for y in this situation. There is no way, even I'm teaching for 10 years, I don't know how to solve for y here because I cannot get y by itself. I can move the x cubed to the other side. I can factor out y, but I still have y inside. I don't know if you see that. I move the x cubed to the right side, I can factor out y. I cannot get y by itself. Does that make sense? So if there's a mixed term with the x and y, then you have to do implicit derivative. So let's take a derivative of this implicitly. So we're going to take this derivative with respect to x. So if I take a derivative with respect to x, what am I going to get? 3x squared, not 2x squared, because you take it down to 3, right? Now I'm going to do the -2, I'm going to do a parenthesis, I'm going to do the product rule there. So derivative of the xy, so I'm just going to focus on this xy part, go into here. And then -2, I leave it outside because I don't want to get bothered with that. So I just take a derivative of xy, so that's going to be y plus what? X dy dx. Does that make sense? Plus 2y, and then every time you derivative of y, there's a chain rule. The x doesn't have a chain rule because it's take derivative with respect to x, but the y does. So dy dx. And what's derivative of 10? Don't forget, 0. So you got 3x squared minus 2y minus 2x dy dx plus 2y dy dx is equal to 0. Now what you're going to do is move all the non-dy dx side to the other side. So minus 2x dy dx plus 2y dy dx is equal to negative 3x squared plus 2y. And I can factor out the dy dx. So dy dx, I can factor out negative 2x plus 2y. I usually don't write this much step. I usually makes a lot more concise. I kind of do 2 step in 1. But this is the first time I introduce it. Now, this is f prime of x. Okay. You're going to do one? I'm going to pick one to do. Let me pick. And there's a chain rule. This other type of chain rule can be more tricky in many cases. And there's also second derivative on implicit as well. So I'm just going to ask you to do this one. X squared minus 6xy squared plus 3y minus is equal to 12. And I want you to check each other with the answers. Yes, Johnson?
For the question you did before, wouldn't that simplify x squared?
The x squared cannot simplify? Wait, what are you talking about? X squared?
It's simplified to x squared because you can cancel out the 2 y's and it'd be negative 3x squared. Oh no, that's 2x. So that's the
No, you cannot do that because you're adding something. So only time you can cancel is a factor.
Oh, right.
So you cannot cancel if something's adding to something. Otherwise, you see this, 2 plus 3 over 2 plus 4. Then it will be 3 over 4, but it's not 3 over 4.
Yeah.
So I want to take a dy dx and see if everybody got the same answer. Remember, anytime you take a derivative with respect to x, there's nothing happen. There's something happen, but you just don't see it. Dx over dx, something happened. I'm gonna record this. It's live streaming, so it's recording. So I'm just gonna take a derivative of this. So it's gonna be 2x minus 6, and derivative of x is gonna be derivative of xy squared is gonna be a product rule. So it's gonna be y squared plus x times 2y dy dx. Does that make sense so far? Plus 3 dy dx is equal to 0. So it'll be 2x minus 6y squared minus 12xy dy dx plus 3 dy dx. Am I going too fast? So I'm going to just do it in one step. dy dx factor out is been negative 12xy plus 3 is equal to negative 2x plus 6y squared. And then dy dx, I kind of see that by moving that to the other side and factor out at the same time. So minus 2x plus 6y squared over negative 12xy plus 3. Does that make sense?